All right, so 4.8 part 2 is about complex numbers, and you may have seen these before and you may not have, and that is perfectly fine. So how do you get an imaginary number? Complex numbers, imaginary numbers, they go together. So up until this point, we have done like square root of 16 is 4, right? Plus or minus 4, but 4, okay? But so that means like what to the second power equals 16, which that question mark would be 4. Agreed? Okay, but then the problem is what happens when you have the square root of negative 16. So that negative throws you off. So that gives you 4, and then you put this little cursive I with it. So that is 4i, and I is what's called an imaginary number. And there's properties that we're going to do with imaginary numbers and things you can do with them. But right now, just know, how do you get an imaginary number? You square root a negative number. Okay? So like for fun, what would be the square root of negative 25? 5i, right? What would you square root to just get I? Well, that would be negative 1. So the square root of negative 1 is I. All right, so that's something you need to know. We're going to get into that a little bit more in just a second. Okay, so let's talk about properties of them. I plus I, when you are adding and subtracting them, you treat them just like a variable. This would be 2i. Oops, sorry, you're trying to get the markers to work. 2i with a little tail on it. Okay, easy. I minus I, that's just 0. Cool, I'm going to skip C for the moment. I times I, or I divided by I, those cancel, that's 1. Okay, those properties work the same. Multiplying is when it gets fun. So let's go back to this. Remember, I is the square root of negative 1. Okay, so for fun, what is the square root of 4 times the square root of 4? Well, that is just 4. Right? Because square root of 4 is 2 times 2, which equals 4. So the same thing could be said for square root of 16 times the square root of 16. That's just 16, right? Anytime you have a square root times itself, it's just that number under the radical. So let's see. Remember, square root of negative 1 is I. So what would I times I be? Well, that would be like the square root of negative 1 times the square root of negative 1, which based off of what we did up here is negative 1. Okay, so this is something you need to have memorized with i's. This is the biggest thing that comes up. I squared, or I times I, is negative 1. That is the other property you need to know. Those two are... If you can memorize those two, you'll be good to go and you'll be able to work with the rest of it. Okay, so I times I, will write it down here. That would be I squared, which we said is negative 1. Okay, let's just do some properties, adding and subtracting, no big deal. Okay, 4i plus 8i, easy. 12i, nothing to it. Okay, this one. 3 minus 2i, in parentheses, plus 4 plus 8i, in parentheses. So on this part gets people, and the part that gets them are the parentheses. Are the parentheses doing anything for you? And the answer is no. There's no number out front of this one that needs to be distributed in, right? And there's just a plus sign, so this is like a positive 1 right here, and if you distribute that in, it doesn't change it at all. So really, you could write this as 3 minus 2i plus 4 plus 8i. All I did was take the parentheses off because they didn't do anything for us. But you will see that in a lot of textbooks and like on your homework. So I just want you to be prepared that these two things are the exact same thing. All right, from here, we just need to combine our like terms. So 3 plus 4 gives me 7. And then negative 2i plus 8i gives me positive 6i. Okay? And that's your answer. You cannot combine real and imaginary numbers. Okay? They're not like terms. You can't combine them. Another thing I want you to know is the mathematically correct way to write this, or kind of like some math grammar for you, is always write the real number first and then the imaginary number second. Okay? So that's just kind of common. Like, that's just how you write it. Alrighty, next one. This one's a little bit different because they're being subtracted. So what do you need to do on this one? You just have to distribute that negative first. So negative 3 plus 4i, and I'm just going to drop this stuff down because those parentheses aren't doing anything because there's no number out front. Then combine your like terms. 9 minus 3 gives me 6. 2i plus 4i is positive 6i. Okay, there's that. Alrighty, D. This one's different, but not too bad. You just need to distribute that 6 in. So that'll be 54 plus 6i. That's it. Can't combine like terms. You're done. E. 3i times 1 is 3i. 3i times negative 2i would be negative 6i squared. But, ding, 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 red flag, we have an I squared. Anytime you have an I squared, you can simplify it, and you need to if you get all your points. So remember, this is I squared is negative 1. So this is like this. All right, just replace the I squared with a negative 1, which would give you 3i plus 6. And then I'm going to write it the correct way with the real number first. So 6 plus 3i would be your answer. Next one, distribute the 6i. That would be 12i minus 24i squared. That would be negative 24 times negative 1. So I have 12i plus 24. Flip it around so it's in the right order. 24 plus 12i. Boom. Okay. Then let's go to this one. Now we have two binomials being multiplied by each other. No big deal, but we do need to distribute. So 3 times 6 gives you 18. 3 times 2i is positive 6i. 2i times 6 is positive 12i. And 2i times 2i is positive 4i squared. Okay, so positive 4i squared, that I'm going to cross off, and that's going to turn into negative 4, right? Because positive 4 times negative 1. And then let's combine our like terms. So I have 18 minus 4, which is 14, plus 6i plus 12i would give you positive 18i. Done. Okay, let's do another one. So distribute 32 minus 8i, negative 12i plus 3i squared. You know, that is actually negative 3. Combine your like terms. So that would be what? 29 minus 20i, I believe. Last one of these, if you want to pause the video and try it on your own, you can. So distribute 12 minus 3i plus 4i minus i squared. So minus I squared is actually positive 1. Combine like terms. So I have 13 negative 3i plus 4i would be what? Positive I. So 13 plus I. Okay, so now let's get to the next part. That was too easy. We got to do some harder stuff, but we are going to use some of that stuff. To divide complex numbers, multiply the numerator and denominator by the complex conjugate of the denominator. That's a mouthful. Do not, this is the number one rule for dividing imaginary numbers. Do not leave any imaginary numbers in the denominator. You can't do it. It's not correct. Okay, you need to simplify them out. So this problem right here, there's a few different things I see in this problem. First, I have an I in the denominator. I got to get rid of it, and we'll talk about that later. But really, my first instinct, this is a fraction. I want to simplify that 8/10. You can divide both of them by 2. So I have 4 over 5i. That's not, that thing was that was optional to do it now, or you could have done it at the end. It does not matter. I just saw it there, and I was like, let's just get it over with now. Okay, so what can I do to get rid of that I out of the denominator? It's okay if it's in the numerator, it just can't be in the denominator. So if you've messed with radicals very much, you may know, but you have to multiply it by something. What would happen if I multiplied it by I in the denominator? Well, that would give me 5i squared, which I can clean up. And remember, what you do to the denominator, you must do to the numerator, because this whole thing right here is 1, right? I divided by I. So you can multiply stuff by 1 all day long. You don't need to worry about having an equation where you can do stuff to both sides. Nope, you can multiply something by 1 all day long. Okay, so that's what I'm going to do. So multiply the top, and you get 4i. Now, let's clean it up a little bit. 5i squared is negative 5, right? So this would be 4i over negative 5. Or if you remember, you could some people don't like that negative being in the bottom. It doesn't matter. Negative 4i over 5, you could write it that way. Or you can move that negative up to the top. Any of these three are correct because they're all the same thing. Okay, let's do another one. Some of you may see, hey, let's simplify those 7s. All 3 terms are divisible by 7, so let's do it. So, and it has to be all 3 terms because there's 3 terms in this. If it's only 2 out of the 3, you can't do that. So that would give me negative 1 plus 1i, or just I, over 1i, or just I. Cool. Now, I need to get rid of that I out of the denominator, so I'm going to multiply it by I, and what I do to the bottom, I must do to the top. So on the bottom, I get I squared, which I'll clean up later, and then go ahead and distribute, because that is a binomial. So that would be negative I plus I squared. All right. I squared is negative 1. I squared is negative 1. I'm going to clean it up to make it look nicer. So negative 1 minus I over negative 1. This answer is perfectly fine. Or if you wanted to divide everything by negative 1, you could have 1 plus I over 1, or even better, 1 plus I. So any of those answers are just fine. This is probably the best. All right, let's keep going. This one. So can I simplify all 3 numbers by anything? No, unfortunately not. Okay, no big deal. So let's multiply it. What do I need to multiply the bottom by to get that I off of there? And the answer is I. So what you do to the top, you must, oops, that's the highlighter, sorry. So I over I. So we have on the bottom 8i squared, distribute that into that binomial, so 5i minus 9i squared. Let's clean it up. That's going to give me negative 9i squared is going to be positive 9. 8i squared is going to be negative 8. So I'm going to write it all together. 9, write your real number first, plus 5i over 8. Good. Okay, now let's talk about this. This is getting a little, this is as tricky as it gets, or pretty much. Okay. So now we have a binomial on bottom, which is kind of a pain in the butt, but it's okay. So don't write this down because it's wrong. I'm going to erase it. So you may be tempted to multiply this by I over I, which is a good thought process because that's what we've been doing on the other one. But watch what happens since it is I over I. So you're going to just, top's going to be I, right? The bottom, you're going to have to distribute that in. That's 3I minus I squared, which ends up being I over, this would be negative 1 times, or negative times negative 1, which would be positive 1. So 1 plus 3I. We have a problem. We didn't get rid of the I in the denominator. We just moved it over. Okay, so we're not going to be, we have to erase all that. We're not going to be able to multiply by I over I. We're going to have to multiply by what's called the conjugate. So the conjugate of a number, you may have seen this with radicals, you may not. You take this sign in the middle of your two terms, or the middle of what you're trying, or the sign in front of what you're trying to get rid of, which is the I, and you multiply it by, you change that sign to its opposite. So instead of 3 minus I, we're going to do 3 plus I. And if you do that to the bottom, you must do it to the top as well. So let's go ahead and work it out. And you'll see why I did that. It's kind of cool how it works out. So go ahead and distribute. So that would just be 3 plus I. Cool, that was the easy one. Now distribute that 3. So 9 plus 3I. And then I'll distribute the negative I. So that would be negative 3I minus I squared. Now, we're here. Look what happens. It's kind of cool. These two right here, positive 3I minus 3I, that cancels. Great. Negative I squared is the same thing as positive 1, right? So now I can put it all together. 3 plus I over 9 plus 1 would give you 10. Double check. Did I get rid of all of the i's in the denominator? Yes. So I'm finished. Cool. Let's do another one. We have another binomial in the bottom, so I'm going to have to multiply it by another binomial. And remember, you only change the sign in front of your imaginary number. You don't change this sign right here. It'll mess things up. Okay, so we're going to do negative 8 minus 9I. We're going to multiply the top and the bottom by that. All right, it's very easy to make a mistake whenever you're doing this by just going too fast. So I highly recommend showing all your steps. I know some of you will be too stubborn for that, but that's on you. Okay, distribute that in. That's going to be negative 24I minus 27I squared over, that would be positive 64 plus 72I. Distribute that positive 9I in, so that would be negative 72I minus 81I squared. Ooh, it's looking real gross, but let's clean it up. So I know this will end up being positive 27. This will end up being positive 81. These two cancel. So now I just need to put it all together. So I have 27 first, because that's the real number, minus 24I on top. And then 64 plus 81 would be 145. Okay, double check. Can you divide divide all three terms by anything? I almost thought 3, but the answer is no, you can't. So that's your answer. 145 is not divisible by 3. Okay, let's do another one. We've got multiply by the conjugate, 5 minus 6I. So go ahead and distribute. 35I minus 42i squared over, let's multiply this out, so that would be what? 25 minus 30i, and the last piece, positive 30i minus 36i squared. Clean it up. That becomes positive 42, positive 36. Those cancel. Put it all together. You have 42 plus 35i over, what is that, 61, I believe. Okay, and I don't believe those can be reduced, so you are done. All right, 3 more, I think. Sweet. I'm gonna go fast, so if you need to rewatch. Okay, so gotta multiply by the conjugate. 6 plus 4i. Distribute. Ooh, this is a binomial times a binomial twice. Our lucky day. So this would be negative 48 minus 32i gross, and then distribute your I. So positive 6i plus 4i squared. Let's do the bottom. Distribute your 6, so 36 plus 24i, and then distribute your negative 4. Negative 24i minus 4i squared. Ooh, 16i squared, almost made a mistake. All right, now that it's looking good and gross, let's clean it up. So this ends up being negative 4. This ends up being positive 16. These cancel. I think that's it, so I just need to combine like terms. So negative 48 minus 4 would be negative 52. And then that would be what? Minus 26i. When you combine the negative 32i plus 6i, and do the bottom, 36 plus 16 to 52. Okay, ooh, these do simplify. Okay, what can you reduce all 3 of these numbers by? The answer is 26. So this would end up being a negative 2. This ends up being negative I, right? Negative 1i. And this ends up being positive 2. So I'm going to put it all together. Negative 2 minus I over 2. Can I simplify again? You may be tempted to simplify those 2's, but don't, because it's a binomial on top. If you're going to simplify, all 3 things need to be simplified. Okay. Let's do one more. So we've got, let's multiply by the conjugate. 5, how many times am I going to do that this video? 5 plus 2i to both the top and the bottom. Distribute. So that would be negative 15 minus 6i minus 20i minus 8i squared all over 25 plus 10i minus 10i minus 4i squared. Okay, clean it. So I got positive 8 right there, positive 4 right there, canceled there. Put it all together. Negative 15 plus 8 would just give me negative 7 minus 26i over 29. Can you reduce that? No. It's a very large fraction bar. Just true. That's okay. All right, that is it. Sorry this video was so long, but there is a lot of material to this. Make sure you do your homework, and thanks for watching. Have a great rest of your day.